Okay, we're going to do electron configurations for molecules, which seems kind of weird, but it is a useful way to communicate what's going on when you don't have the room to write a molecular orbital correlation diagram, or you can get away with not writing one, which is probably not the case if I'm asking you to write one, but you can communicate this information in the same way. It's the same principle as for atoms, which is that we're going to list the orbitals and their contents in order. So, done. Exactly like we did for atoms. So, we're going to practice with O2. So, I have just brought over the MO correlation diagram for O2 that we made at the end of the last video. And if I were to write the electron configuration for this, I will start at the lowest level, write the orbital, write how many electrons are in it, move on to the next orbital. Now, this is for valence only because I don't have my 1s listed here, and that's okay. We don't need to do a shortcut or anything like that. We can just label it as valence only, or we could go back and make sure we include the 1s. If I'm asking you to do it, valence only is fine. So my lowest energy orbital is the sigma 2s, so I'm going to list that. It has 2 electrons in it, so I'm going to do a superscript 2. Then we get to sigma star 2s, which has 2 electrons in it. Sigma 2p is next, and it has 2 electrons. Then pi 2p, it has a total of 4. So we list this the same way that we did for the individual atoms, which is just, yeah, there's multiple orbitals in this set. I'm just going to name it and then put the total number. So pi 2p4, and then pi star 2p2. And that is my electron configuration for O2 from its MO correlation diagram.